The diagram show an empty container in the form of open triangular prism. The triangular face are equilateral with the side of x cm, and the length of each rectangular face is y cm. The container is made from thin sheet metal. When full, the container holds 200 square 3 cm cube uh, of water. Okay, so we need to show that the A total surface area is this. Okay, so it is the open triangular prism. Open triangular prism, that means over here you can pour water inside. So this part, okay, is open. Okay, we have nothing here. Okay, so for this kind of question, normally we will have two equations. The first equation is to relate that the two formula. So the two formula is we have the this one is a equilateral triangle. So I can cut into half. Okay, then this one will be x over 2. So Pythagoras theorem. So this height will be the square root of x squared minus x over 2 square. Okay. But it will be little bit difficult. Never mind lah. Cannot. Okay. So we have the square root of x squared minus x squared over 4. So divide by 1, multiply by 4. So it will become the square root of 3x squared over 4. It will be square root of 3x squared over 2. Okay, because square root 4 is 2. Okay. So the volume will be the x half. The volume is the area times height. The volume is the area times height. Will be the uh 1 over 2 x times the square root at 3x squared over 2 multiply with 1. Okay. So this is equal to 200 square root 3. Okay. So this equal to 200 square root 3. So it is given that the V is 200 square root 3. Okay, so from here we can get the relationship between this so this one is actually is square root 3 x over 2. Oh, square root 3 x over 2. Okay, it's something like this. Like this will be easier. Okay, so we can see that in the equation for the area here, they don't have 1. So that means I can write the y as the subject. So the y equal to, so this square root 3 we can cancel. Okay, and then this 2 I multiply there. Okay, and then this 2x we divide. So we have the 200 times 2 times 2 over x times x. So we have the 800 over x squared. So the surface area, we have the uh, x times y, two face, and then the area is this half times x times this is the area. So we have two of this. Okay, two of this plus 2xy. Okay, then we have the square root 3 over 2x squared plus 2x multiplied with 800 over x squared. Then we have the square root 2 over 3 over 2x squared plus 1006 over x. So square root 3 x squared over 2 plus 1006 over x. So actually these two, wait, this is uh the x square shouldn't be inside, it should be outside. Hmm. Yes. So the equation here, this one, they make a mistake. Okay. Easier way here to find the area. Okay. That is, we have a 60-degree here, and this is x also. So we know that the A is 1 over 2AB sine C. Okay. So the area here is 1 over 2 x times x and then sine 60. Sine 60 is square root 3 over 2. So half x squared square root 3 over 2. It will be square root 3 over 4 x squared. Same with this one, square root 3 over 4 x squared. Okay, so we have this one is square root 3 over 4 x squared. Okay, then it will be easier. Hmm. Volume is the square root 3 over 4. So this is the volume. Area. Okay. So we it is given that x and y can be varied, find the stationary value of a and determine its natural. So for this one, we know that the a is square root 3 over 2 x squared plus 1006 x power negative 1. So we have the dA dx equal to square root 3 over 2. No, we multiply with 2. It will be square root 3x minus 1006 x power negative 2. Then the second derivative will be square root 3 plus 3002 x power negative 3. Okay, so we can rewrite this as 3002 over x cubed, and this is square root x minus 1006 over x squared. So normally I will after I get this, I will straight find the second derivative. Okay, it will be easier. But I will write it this way so that is the final result that we normally write for the indices lah. Okay, so stationary point, that is the dA dx equal to 0. So we have this one equal to 0. Okay, so this equal to 0. Okay, so we have the square root 3x equal to 1006 over x squared. So we have the x cubed is 1006 over square root 3. Okay, so the x is, wait, 1006, wait, this one, we have the cube root over 2. Okay, so we have the 1006 divided by square root of 3. So the x will be this. Okay, then the second derivative when x equal to 1006 over square root 3, it will be square root 3 plus 3002 over 1006 over square root 3. It is a positive value greater than 0, so it is a minimum. Okay, so the area, okay, the area will be this one. I substitute it, so the area will be the square root 3 over 2, 1006 over square root 3 square plus 1006 over 1006 over square root 3. Okay, so we have the uh, square root 3 over 2 x squared plus 1006 over x. A mistake here. So the x should be the cube root of this. Okay, so we have the uh this one calculate. So is the cube root of 1006 over square root 3. So it is 246 point something. Okay. So it is 246.4. Okay. Cm square. So just now this one is actually calculate 9.74. 9.74. So this one is 9.74 over 9.74 is positive, greater than 0, minimum. Okay, so the answer provided in the book is 246. So my answer is correct. Okay.